If you've ever looked closely at your car's tires, you might have noticed that some of them have arrows or the word rotation printed on the sidewall. These markings aren't decoration, they tell you which direction the tire is designed to roll. Mounting a tire backwards might seem harmless, but it can actually cause serious performance and safety problems. Modern tires aren't perfectly symmetrical. Many are designed with directional tread patterns, which means their grooves and channels are angled in a specific way to push water, snow, and debris outward from the center. This helps maintain grip and prevent hydroplaning on wet roads. When a directional tire is mounted backwards, those channels face the wrong way. Instead of expelling water, they collect it, forcing moisture toward the middle of the tread. This creates a thin film of water between the rubber and the road, exactly what engineers try to avoid. The result is reduced traction and longer braking distances, especially in rainy conditions. Even if the tire still looks fine from the outside, its ability to grip the road efficiently drops dramatically. Drivers may feel the car sliding or fishtailing when cornering or stopping. Directional tires also play a big role in high-speed stability. The angled tread pattern helps maintain even contact pressure as the tire rotates. Mounted backwards, that balance is disrupted, creating uneven forces that can cause vibrations or instability at highway speeds. Before a new tire design ever reaches the road, engineers run extensive wind tunnel and water dispersion tests. High-speed cameras track how droplets move across the tread at different angles, confirming the optimal rotation direction. It's an exact science. Small deviations can completely change how a tire behaves in wet conditions. Some tires are labeled asymmetrical instead. These are designed with different tread zones on the inner and outer halves of the tire. Mounting them incorrectly, flipping them inside out, also causes handling issues, though in a different way. The outer shoulder of an asymmetrical tire usually has larger tread blocks for better cornering grip, while the inner side features smaller blocks and channels for water evacuation. If reversed, the wrong surfaces touch the road in the wrong situations. In wet turns, that means less cornering stability and more risk of losing control. In dry conditions, braking may feel less responsive because the softer inner zones are doing work they weren't designed for. The overall driving experience becomes unpredictable. Manufacturers design tread patterns using advanced simulations and track testing. Every groove, ridge, and void has a purpose. Mounting the tire backwards undoes that careful engineering, like wearing your shoes on the wrong feet. Possible, but clearly not optimal. Even tire noise can change. When reversed, the airflow through the grooves shifts, creating unusual humming or whirring sounds that weren't present before. That's a subtle but clear sign something isn't right. To avoid these issues, always check for directional arrows or outside/inside labels before installation. Tire shops normally pay close attention, but mistakes can happen, especially if tires are rotated or swapped manually at home. In short, tires are precision-engineered tools. Mounting them backwards might not cause immediate damage, but it compromises safety, efficiency, and comfort. The next time you change or rotate your tires, make sure each one is facing the right way. Your grip, stability, and peace of mind all depend on it. That's it for today's video. If you enjoyed exploring with me, don't forget to subscribe to Science Lab, where we turn everyday things into scientific discoveries. See you next time.